Hello and welcome back to my organic chemistry video. So today we're going to be going over nucleophilicity, and you guys are in luck because you're getting 2 videos in the span of 1 day, so Merry Christmas early. With that being said, what is nucleophilicity? Well, I like to think of nucleophilicity as molecules that are electron rich, and they are willing to give up those electrons. So for example, something that looks like this would be a nucleophile, and something that looks like this would be your electrophile. Now the nucleophile gives its excess electrons to the electrophile, forming a new bond, like that. And that's how I like to think of nucleophilicity. But what becomes complicated is determining what a better nucleophile is and which molecule is more nucleophilic. So with that being said, I developed a little chart to help you guys. So this chart includes basicity, charge, sterics, and the atom itself. Now looking at basicity, the more basic, the better the nucleophile. Looking at charge, that just means it has a negative charge, it has excess electrons. Now it's not always going to have a negative charge, so don't put that in your mind, but it helps because if you see a negative charge compared to a positive charge, we know that the negative charge is more nucleophilic than something with a positive charge on it because it's more electron rich and it's more willing to give away those excess electrons. The next thing is sterics. Now looking at sterics, nucleophiles that are sterically unencumbered are better nucleophiles. So what does that mean? That means that this is a better nucleophile than this, because this on the left is sleeker and can attack an electrophile more efficiently. This is thicker. So think of it like a rocket. So when you think of it like a rocket, rockets are sleek and slim and they're aerodynamic and they can go in and they can just attack that electrophile. That's how I like to think of it when thinking of sterics. Now the next thing we're going to look at is the atom itself, or the periodic trends pertaining to the atoms. As you go to the left on the periodic table, you get a better nucleophile. And that is because the more or the less electronegative the atom is, the better a nucleophile it is. And as you go down with the halogens, you get a better nucleophile. So iodine is a better nucleophile than fluorine. However, you can also think of it as size. So sulfur is larger than oxygen, so sulfur is a better nucleophile than oxygen. And those are the periodic trends you really need to know for nucleophilicity. Now, the next thing you got to keep in mind for nucleophilicity is resonance itself. So when comparing these two molecules, it's 2 oxygen atoms with a negative charge. So these oxygen atoms both have excess electrons. So they're both nucleophilic. But which one is more nucleophilic? Well, this is when resonance comes into play, because we can resonate these electrons here and then resonate them here, and that would then give you this. Now the molecule on the right, when you resonate this here, all you get is this. And you can't resonate that charge onto another atom. So now we can look at the atom itself, and we know that carbon is a better nucleophile than oxygen. And since this can share the electrons between oxygen and carbon, and this cannot share those excess electrons with carbon, this would be your better nucleophile. And that's how resonance really plays a role in nucleophilicity. Now with all that being said, let's take a look at some examples, and feel free to pause the video once I get to the next page and try them on your own, or just sit back, relax, take a sip of your soda pop, whatever you're drinking, and just listen as I explain which one's the better nucleophile and for what reasons. So first example, same molecule. However, the molecule on the left has oxygen with excess electrons, and the molecule on the right has carbon with excess electrons. So you can think of this 2 ways. We can look at the atom itself, or we can look at basicity. And I spelled basicity wrong, but I really spelled basicity wrong. But once again, this is organic chemistry, not spelling. So let's look at atom first. This is carbon, and this is oxygen. And we know that carbon is a better nucleophile than oxygen. So perk for this molecule. Now when looking at basicity, the one on the right is also more basic. The conjugate acid of this molecule is more basic than the conjugate acid of this molecule. So we then know that this is the better nucleophile. Next example. So we have two oxygens with excess electrons, both nucleophilic. However, once again, this is going to be sterics. This is thicker, and this is sleeker. This is more likely to be able to attack an electrophile and give up those excess electrons than this. So, since this is sleeker, this is your better nucleophile. Next example. This one, there's no negative charge, so we don't really know where the nucleophilicity is on this molecule, but we can determine which molecule is more nucleophilic via basicity. Got it this time. There we go. Spelled it right. Basicity. So, which of these molecules is more basic? Well, we know this is more basic than this. This is more acidic. So, with that being said, this is your better nucleophile. Next example. This is basically the exact same example as the resonance example. However, it's sulfur. But once again, the molecule on the left can perform resonance to get that negative charge on the carbon. Here, you can't do that. So since this can share the negative charge between sulfur and carbon, carbon is a better nucleophile than sulfur. So this is your better nucleophile. Final example. So once again, we're just comparing two molecules are basically the same. However, you have sulfur versus oxygen. Sulfur is larger than oxygen, so sulfur is a better nucleophile than oxygen, therefore making this your better nucleophile. So, with all that being said, I hope this helped. It's a pretty quick video on how to determine nucleophilicity. You might have to do it for like maybe 4 questions on the exam, but I definitely hope this helped. And if you have any questions, leave a comment below. And I hope you guys stay frosty. Have a wonderful night.